We're going to solve a rational inequality. To do that, we'll start by finding some numbers that we can use to break a number line into intervals. We're going to first solve the related equation that is formed by replacing the inequality symbol with an equal sign. So we have x minus 2 over x plus 3 times x minus 1 is equal to 0. And this will be equal to 0 when the numerator is equal to 0, and x minus 2 is equal to 0 when x equals 2. That will be one number we use to divide the number line into intervals. We also want to look where the expression is undefined. The expression is undefined when the denominator is 0. The denominator is in factored form. We can see that when x equals -3, this factor will be 0. And when x equals 1, this factor will be 0. So both -3 and 1 will make the denominator 0, and the expression is undefined for those values. Now we use the values -3, 1, and 2 to divide a number line into 4 intervals. -3, 1, and 2. And I'll label the intervals A, B, C, and D. And I'm looking at the inequality x minus 2 over x plus 3 times x minus 1 is greater than or equal to 0. I will test one number from each interval. Because of the way I chose or found the numbers -3, 1, and 2, if I can test one number in A and it makes this inequality true, all interval A will be part of the solution set. If one number in A is false, then none of interval A will be part of the solution set. So for A, I choose a number in this interval A, which I'm going to choose -4. And I substitute -4 for x. -4 minus 2 is -6. -4 plus 3 times -4 minus 1 would be +5. And my question is that greater than or equal to 0? That's a negative number that will not be greater than or equal to 0. And that tells me that interval A will not be part of the solution set. I repeat this process for intervals B, C, and D. For interval B, I'm going to choose to test 0, since that's in interval B. 0 minus 2 is -2. 0 times 3, 0 plus 3 times 0 minus 1 is going to give me a -3. And is that greater than or equal to 0? Well, that would be 2/3. 2/3 is greater than or equal to 0. The answer is yes. So interval B will be part of the solution set. For interval C, I can't choose an integer because I'm right in between two integers, so I'll test 1.5, or 1.5. 1.5 minus 2 is -0.5. And then I multiply 1.5 plus 3 times 1.5 minus 1, and I get 2.25. I have a negative number divided by a positive number. Will that be greater than or equal to 0? No, that's negative number. Negative numbers are not greater than or equal to 0. So interval C will not be part of the solution set. One more. Interval D, we will test 3. 3 minus 2 is 1. 3 plus 3 times 3 minus 1 is 12. Is 1/12 greater than or equal to 0? Yes, it is. So interval D will be part of the solution set. So when I write the solution set, I'm looking at the interval B, which is -3 to 1, and interval D, which is 2 to infinity. Does it include the endpoints, -3, 1, and 2? Well, the key to that is looking at this symbol, greater than or equal to. Since the equal sign is there, any of those numbers that make this expression equal to 0 will be included. 2 then would be included. Negative 3 and 1 are not included. This expression is not defined for negative 3 and 1. So I write the intervals, the union of the intervals b and d as the set of all x such that negative 3 is less than x is less than 1, or x is greater than or equal to 2. Using interval notation, I can write the interval from negative 3 to 1, not including either negative 3 or 1. The union of that interval with the interval from 2, including 2, up to infinity.